So we're going to look at question 3a now on the 2019 P2 paper. So it's a binomial expansion. We could just use the formula in the formula book to work out each of our coefficients, but I'm actually going to do this differently using a table method and using the coefficient button on the calculator. So we're told we only want the first 4 terms of this expansion, and the index on it is 12. So if we have a look at the first term, we can just use our calculator to work out the coefficient here of 12 choose 0, which we know of course would be 1, just from Pascal's triangle, and then we multiply it by 1 to the power of 12 multiplied by the next part of the bracket to the 0. Okay, now I'm sure we all know that each one of those actually is 1, so we can just write 1 here. Writing it like this, of course, we can look at the indices 12 and 0, and of course they add up to 12, which is what the index is on our expansion. Alright, so that's an important little check that we can use to see whether we're doing it correctly, because we'll have a little pattern going on. So let's have a look at the second term. So for the second term, we're going to use 12 choose 1 multiplied by 1 to the power 11. Okay, multiplied by, and for this one, we can now raise it to the power 1. So if you use your calculator, you'll find that 12 choose 1 is actually just 12. And then we can multiply that by x over 4, which of course, if I've got enough space, which I do, cancels out nicely to give us 3x. So we can move on now to our third term. So right here, so now we're up to 12 choose 2 multiplied by 1 to the 10. Now these have to add up to 12, so what I know is that on this term here, this part here, to add up to 12, that this must be 2, so we've got a squared going on. Now, using your calculator to find out what 12 choose 2 is, we get 66. I'm not going to bother writing out the 1s to the power 10, because we know that's just going to give us 1. So then we're multiplying that by x squared, and don't forget to square the denominator, which gives you 16. Now, what goes into both of those? Well, we can certainly take 2 out, which is going to leave us with 8 and 33. So let's go there. We've got 33, and that is over 8x squared. Right, for the fourth term then, 12 choose 3 multiplied by 1 to the 9 multiplied by x over 4, and we're going up, so this is a cube now, so they both add up to 12, but also you'll have noticed that we're going up, haven't we, here? So here there's a 1, here there's a 2, here we've got a 3, so it's a nice little pattern going on. Again, we've got 12, 11, 10, 9, so this is quite a nice little way of doing it. So let's have a look at that. 12 choose 3 is actually going to give you a coefficient of 220, and we're multiplying this time by x cubed over, and 4 cubed is 64. So we can take 4 out of all of these, and that would cancel down quite nicely, he says, to give us 55, and we divide 64 by 4 over 16 x cubed. So each of our terms, there's 1 here, there's 1 here, and 1 here, and then obviously the 1. So we've done the working out. Now the only danger of doing this method is that we haven't actually written the solution down. Right, this is the only danger of doing it like this. So we need to write that all out. So we've got 1 plus 3x plus 33 over 8 x squared plus 55 over 16 x cubed. And that is our expansion, which I've done quite a lot of working out there. You can certainly condense it if you feel brave and almost do it as one go. But in terms of the marks that you're going to be getting, they're looking for the coefficients and the construction of this to get to this answer for your 3 marks. So you get 1 mark for the answer bit at the end. Actually, I think you get 2 for this section, and the rest just 1, I'm afraid. But that's a 3-mark question.